Hello everyone, welcome to CodeGrad, and today we'll have a discussion and implementation of the pre-processing techniques in NLP. So as per the definition, it refers to a set of techniques used to clean, normalize and prepare raw text for NLP tasks. And why it is important or why it matters is it is often required to clean the messy data, model accuracy is improved and also the understanding. For tokenization, embedding and learning pattern, it is very important. Can you think of some common issues in raw text from social media or chat? So generally in social media or chat, we don't use proper grammar. So in this task, preprocessing techniques are very important. Moving on with the next slide. Goals of preprocessing in NLP. We have to remove noise and inconsistency, standardize input for models, reduce vocabulary size, improve computational efficiency, and enhance semantic understanding. So generally these tasks are completed when we do preprocessing in NLP. Now it is especially important before applying LLMs or training classic ML model. So it is very important technique for basically where we include text data. Now, the first part of the preprocessing technique is lower casing. We convert all letters to the lowercase pattern. Like for apple, we are converting it into lowercase apple, where all the letters in the word are lowercase. And we should try avoid treating apple and this apple as different tokens. So it is basically used to reduce case-based duplication in vocabulary, useful for tasks like sentiment analysis, classification, etc. Now, why might you keep lower casing in a name entity recognition? As in name entity recognition task, we have to maintain the casing pattern which was original. So if we convert this apple to lowercase apple, it will be treated different. So in that task, we generally avoid lower casing. Now removing punctuation and special character. Punctuation adds noise in many NLP tasks. So these are the examples of punctuations which are normally in the text data. Emojis. Now this is an optional task, but in some cases we need to remove extra symbols. Example hyperlink. It can be an hash or another examples are also there where we have to remove it for increasing the accuracy of the data. Helps with linear tokens for models, but consider task context before removal. Stopword removal. Now stopwords are commonly used words like is, at, in, and the, and they generally don't carry any strong meaning individually, and removing them reduces dimensionality. Now we will try to skip stopword removal if contextual meaning matter. So if you want to understand the complete context of any sentence or the tense of any sentence or the meaning of any sentence, the whole meaning of a particular sentence, then at such part we try to skip stopword removal. So tokenization is another part of the preprocessing technique. Now here we break down the sentences into words, subwords or characters. For words we use word tokenization. For subwords we use byte pair encoding, word peep, and another sentence piece is also available. For character we have character level modeling. Tokenization is the first input layer in most NLP pipelines and LLM. Now there is a question here: what issues might arise when tokenizing non-English or mixed language text? So this is the task you have to complete where you can get the understanding where the non-English or mixed language texts are available, and if we do tokenization, what issues we may get. Now, lemmatization and stemming is also a part of the preprocessing techniques in NLP. It reduces the word to their base root form. For stemming, it is an aggressive pruner, so we try to cut the word here. For example, for running, we did run. It is a rough cut. In lemmatization, we are also trying to reduce the word to their base form, but here in lemmatization, we are using a word net dictionary. So basically, we are searching for the word. We are searching for the prune word in the dictionary. If any word is available, prune word is available for the word running. And if we find any word, now here we have found run. So it has spared the word run here. Lemmatization is more accurate, but it is slow as we have to search the whole word net dictionary for the word, for the prune word. But as in stemming, it is an aggressive pruner. Removing numbers and URLs. Numbers and URLs may add noise in tasks like sentiment or token modeling. When we have to understand any sentiment of the text data, at that time we do not need numbers. And in the case of the topic modeling, we also don't need numbers. So at such task, we have to remove numbers. The relevant in tasks like invoice extraction or financial summary. But we cannot remove the numerical data as it is very important in the financial case. So we tried avoiding numbers in such scenario. Rule is if irrelevant to context, retain if they carry meaning. If it is irrelevant to context, then we should remove. And if it is retaining any information, then we should keep the number format. Handling contractions as lines, convert informal phrases. For don't, we have to convert to do not. For gonna, we have to convert it into going to. And for lol, laughing out loud. Especially important in social media, chatbots and voice transcript. So as we discussed earlier, in generally in social media chat, we use the short form of the word. So we try to convert it into, generally these are contractions, and converting it into original word is contraction mapping. Now dealing with misspellings and repetition. Generally in textual data, it is generally messy data. So always we don't have any correct spellings of word for each and every word. So we have to take care that in mind. And repetition are also what we can say normal in the textual data. So that should be avoided. By that we are cleaning up the data. So for example, we have two words so who is repeated multiple times which were not needed. Spelling error for generally, for example, for spelling itself, we sometimes use single L. So we should try to avoid misspelling. Techniques include spell correction, regex patterns, and normalization. We have multiple libraries for spell correction, regex pattern. We can import RE library for the regex pattern and handling the textual data and normalization, lower casing the data. That is the most important example for normalization. Where would be spelling correction be risky to apply? That is the question for today's part here. And you should research this question and answer so you can get the satisfied answer. Preprocessing in LLM pipeline. In modern LLM workflows, tokenization and lower casing are handled automatically. So generally when we feed the data to the LLM model, we don't need to do tokenization and lower casing, and that is totally handled by the LLM model. Some steps like stopword removal are kept to retain full context. Stopwords are also not removed by the LLM part to understand the full context. Prompt formatting becomes the most critical pre-processing task. Generally, when we handle the LLM part here, we generally deal with the prompt engineering part. So prompt engineering is the most critical step to get the expected answer from the model and to avoid the hallucination part. Traditional versus LLM pre-processing can differ, always align with model type. So it generally depends upon our task. If you are using traditional NLP techniques, then pre-processing is very important. And for the LLM pre-processing, we don't need much pre-processing steps, so that can be avoided in the LLM pipeline. Summary is pre-processing improves model efficiency, clarity, and performance. Steps include lower casing, tokenization, stopword removal, lemmatization, etc. Choosing techniques based on the task and model type. Be mindful of what might be removed and how it affects meaning. You have to take this is generally very important. For which task we are generally using the pre-processing technique, that is very important. Like for the name identity recognition, we should avoid using lower casing. Which pre-processing step would you apply before summarizing customer reviews using an LLM? And when might aggressive cleaning actually harm model accuracy? These are the questions you need to have a thorough conversation with an LLM, and we can get the expected answer. Now we basically start with the implementation part of the pre-processing technique. First of all, we'll start with tokenization. Now, in tokenization, token basically stands for basic unit of text. It is a basic unit of text. And tokenization is converting text data into basic unit. So, for example, you have string, hello, how are you? Now, if I use string dot split, this is also one method of tokenization. By using split, we have distributed different words, and each word is a token. Now, the second example for tokenization is word punk. So, for that part, we need to import NLP, and we will use word punk tokenize for the string. So, it is working same as split here. Now, we will input word tokenize and send tokenize, and we will see how it works. Now, we'll see the string. We have a string, hello, how are you? Now, we will use word tokenize. We will use a different example to understand the working of both. Ice cream will cost $14, $8.98. Sentences. Hello, how are you? Really introduction break here. Goodbye. Okay. Usually acting. We'll see what tokenized. So how differently it is working from split here by word tokenized. It is also treating question mark different, dollar sign different. Full stop it has been treated as different token. And if we use swing dot split, so in this format in split, the dollar has been assigned with the number here. No separate token for question mark or full stop. But in word tokenized, it was treated as another token, different token. Now we will see the send tokenized, how it works basically. Okay. Now this send tokenizer is basically acting as sentence tokenizer. So in this part, after full stop, they will be treated as different tokens. So if we print a string, yeah. So after the full stop and the question mark, we have different tokens. Now we'll see the word punct tokenize, how it printed the string. Okay. So in word punct, some numeric formats are also treated as different tokens. So hyphen is also treated another token. So in this way, different tokenizer can be used as per our use. So in WordPunk, more tokens are created for hyphen also, for full stop, for dollar sign. Some numerical characters are also treated as different tokens. Before the full stop, it was treated as different token. Dollar was treated different token. These 989 number has been treated as different number, different token here. There is another tokenizer from NLTK. We'll import that. It is called as white space tokenizer. Generally, it will split the data into different tokens by by using or filling the gap. If there is space between any two words, it will be treated as different tokens. Now moving on, next topic is lower casing. So converting uppercase data into lowercase data is generally done in the lower casing, and we'll see how we can use that. For example, we have word Abhishek, and we use the inbuilt function or lower. It has been converted to lowercase. In NLP terms, cape and uncase are the two formats used where uncase is lower and case is maintaining the data how it is. If the data is in upper, some data is in uppercase, so that would be treated as case. Now, for more examples for lower casing, so we have basically the inbuilt function, the lower, can be used to convert any type of text, maybe it in uppercase or maybe it in title case. So everything will be converted into lower case with the help of the lower function. Now the next part is stopword removal. We'll assign one variable. We'll try to use English here. The first one. And when we print stopword, So these are the top words available. A, about, above, after, again, again. They individually don't have any specific meaning. So in sentiment analysis task, we generally try to avoid the top word. For example, you take a string. Hello, how are you? I want to remove top word from this string. So we'll type word in string dot split. If word in SW, the word not in SW, print word. So hello was the only word which was not available in the top word list. Rest all these words are top word. So in this way you can remove top word from a particular string. Now moving on with stemming and lemmatization. First of all, we'll see the stem part. So from NLTK dot stem import both the stemmer. We have three types of stemming here. Dot stem import mobile and from NLTK dot stem import language system. Now we can see how Snowball handle different languages. What capabilities Snowball can have. So it can handle Arabic, Danish, Dutch, English, French, German, Portuguese, Romanian, Russian. These are the languages which can be handled by the Snowball stemmer. We will try to see if stemmers use. For that we'll use photo stemmer for Snowball stemmer and for Lancaster. The Snowball stemmer, as it is used for different languages, we have to specify which language we are using. So we'll mention it in English. Now we'll see for different words how it extend or prunes the word. For example, I'm using the word mice. We'll print tema or the tema dot tab. And we do for global tema dot tem. We'll mention the word Lancaster tema dot tem. The word. So for Porter and Snowball, it hasn't thrown any letter form here. But for the Lancaster, that totally changed the meaning of the word. So originally it was Mike, but it has turned into Mike. It is not good. So tremor basically is used as an aggressive pronoun. It does not search for any particular word or pronoun word in the word dictionary. So after pruning the word, it might generate a meaningful word. So Snowball, tremor, and another tremors are generally avoided while aggressively pruning the word. Now we'll take a different word for example. Language or running. Basically, you'll pick running and then you just copy paste it. Okay. So it has generated a proper tone word for running. It was run for all the parts. Word of number and Lancaster. Another word will be maximum. Okay. It hasn't proven for a Porter of novel, but for Lancaster, it has proven aggressively, and it is not. We are not getting any proper tune word after using the Lancaster. Now we will move on with lemmatization part. As we use word dictionary backend to search for tune word in lemmatization. So we'll download WordNet and from NLTK or STEM import word net, lemmatizing, lemmatizer dot lemmatize. Okay, we need to define for lemmatize. We'll see the word maximum. It was not previously proven earlier in the framing part. These both techniques are basically used to tune the word, so the complexity of the architecture becomes, or the complexity of the textual data becomes simpler. Now, we didn't find any word for maximum in the word dictionary prune word, so it gave the result as the original word. We'll try another word. Running. It is not a string. Now, if we consider it as verb, then it is lemmatizing or pruning the word. Now here frame we use it as a verb. Let not. So this is how lemmatizer works basically, and we can use lemmatization in both for framing or for pruning the word. Now moving on with the next part. Next one is the contraction. So that for that we need to install contraction. We'll import contraction. Now generally we see that for I am we generally mean it as I am. So that would be the basic working in the contraction. We'll see the implementation part. Contraction dot fix. This is the basic working of the contraction. We'll try another word here. We will, with giving correct one. For example, we'll take another. Oh, okay. It is showing correctly. So this is the basic working of the contraction, and we can use it in our textual data, make our data simpler, and remove mistakes from the data. Now next is spelling correction. Generally, we make meaning spelling also. So that is important context when we're dealing with the preprocessing techniques in NLP. Now for that, we need to install byte spell checker from spell checker. What? Okay. Spell checker. Spell dot correction. We will give some do some wrong spelling mistake here. We'll take the word spelling only. Now we'll use another word here. Spell dot correction, and we will use the word attendee. So it has a spread and. But for SND, it can be and also. It can be send also, fan, sad. So multiple words can be formed here. So we can also actually see how many candidates are present. For that we have spell dot candidate and we give the word SND. So we have and IND, tag, tan, send, did. Another was going to have any meaning here. So these are the basic techniques we use as a pre-processing technique as for cleaning our basic data. Hope you guys understood the importance of the pre-processing techniques in NLP, and we'll meet you guys for the next topic. Till then, bye.